Hey, have you ever wondered why a tiny spider can take down something much bigger than itself? Or why some venoms are actually saving human lives right now? Hey everyone, I'm Ben. Welcome back to English Story Mode, the podcast where we learn English while discovering the coolest science, nature, and tech facts together. Today we're talking about something super fascinating and a little bit scary: how venom works in nature. So grab your coffee, get comfortable, and let's dive into this wild world together. Okay, so first things first, what exactly is venom? I used to think venom and poison were the same thing, but they're totally different. Venom is something an animal injects into you through a bite or sting. Think of it like nature's hypodermic needle. Poison, on the other hand, you have to touch or eat. Pretty cool difference, right? So when we're talking about venomous snakes, spiders, and scorpions, these animals are basically walking around with their own chemical weapons factory. Now, why did animals evolve venom in the first place? It's actually genius when you think about it. Imagine you're a small snake trying to catch a mouse. Without venom, that mouse could fight back, bite you, scratch you, maybe even escape. But with venom, one quick bite and the mouse's nervous system shuts down. Game over. It's like having a superpower. Venom helps animals hunt prey that's way bigger or stronger than them, and it also protects them from predators. Nature is basically playing chess while we're playing checkers. Let's talk about snakes first, because wow, they've got some serious chemistry going on. Different snake venoms work in completely different ways. Some venoms are hemotoxic. That means they mess with your blood and tissue. They basically turn your blood into jello so it can't clot properly. Other venoms are neurotoxic, which means they attack your nervous system. They're like hackers breaking into your body's computer system, shutting down the signals between your brain and muscles. Can you imagine? One tiny bite and your whole communication system goes down. Take the Russell's viper, for example. This snake's venom is so hemotoxic that it can cause internal bleeding throughout your entire body. Your blood vessels start leaking like broken pipes, and your blood can't clot to fix the damage. It's simultaneously fascinating and terrifying. Then you have snakes like the black mamba. Its venom is primarily neurotoxic. It contains something called dendrotoxins that block potassium channels in your nerves. Without getting too technical, imagine your nerves are like electrical wires, and this venom is like cutting those wires one by one until your muscles can't receive signals anymore. And here's something that blew my mind. Cobra venom can kill you in 15 minutes, but a coral snake's venom might take hours to show symptoms. It's like the difference between a lightning strike and slow-acting poison in a mystery movie. The coral snake's venom is sneaky. It quietly shuts down your breathing muscles while you're still walking around thinking you're fine. Nature can be pretty terrifying, but also absolutely fascinating. Now let's talk spiders. Most people are afraid of spiders, but honestly, their venom is incredible from a scientific perspective. Spider venom is like a cocktail of different toxins, each one designed for a specific job. Some toxins paralyze the prey, others break down tissues so the spider can basically drink their meal like a smoothie. Gross, but efficient, right? Black widow venom attacks your nervous system and can cause muscle cramps so painful that people have described it as feeling like they're being electrocuted. But here's the crazy part. Most spider bites won't kill a healthy adult human. We're just too big. Let me tell you about the Sydney funnel web spider. This thing is like the spider world's ultimate predator. Its venom contains a compound called atracosin that specifically targets primates, including humans. That's right, this spider's venom evolved to be extra effective against creatures like us. The venom causes massive nerve dysfunction, and without antivenom, it can kill an adult human in as little as 15 minutes. Talk about dangerous dating. Scorpions are another level entirely. Their venom is so complex that scientists are still discovering new compounds in it. The Arizona bark scorpion has venom that's specifically designed to work on mammals, which includes us. It causes this thing called roving eye movements, where your eyes just start moving around uncontrollably. It sounds like something out of a horror movie. But most scorpion stings are just really, really painful. Think of the worst bee sting you've ever had, then multiply that by 10. But here's where it gets really weird. Are you ready for this? The platypus. Yes, that cute, weird duck beaver thing from Australia. I remember the first time I learned that platypus males have venomous spurs on their back legs. I was like, wait, what? Nature is wild. The male platypus has these hollow spurs that inject venom, but only during mating season. It's like they have seasonal weapons. The venom causes excruciating pain that can last for weeks and doesn't respond to normal painkillers. Imagine explaining that to your doctor. Yeah, I got attacked by a platypus. But wait, we can't forget about the ocean. The sea is basically a giant swimming pool full of venomous creatures that would make a horror movie director jealous. Let's start with the blue-ringed octopus. This little guy looks absolutely adorable with its bright blue rings, but it's carrying enough venom to kill 26 adult humans. And here's the scariest part. There's no antivenom. The venom contains tetrodotoxin, which blocks your sodium channels, basically meaning your nerves can't send signals. You stay completely conscious while your body slowly shuts down. Then we have sea snakes, which are basically the ocean's version of cobras, but their venom is often even more potent. The beaked sea snake has venom that's about 10 times more toxic than a king cobra's. And don't even get me started on jellyfish. The box jellyfish from Australia has tentacles covered in millions of tiny harpoons called nematocysts. When something touches them, these harpoons fire like microscopic missiles, injecting venom that can stop your heart in minutes. Yeah, I'm staying out of Australian waters. Now here's where venom gets really exciting. Medicine. Scientists are like treasure hunters, digging through venom to find life-saving compounds. Remember how I said venom is like nature's chemical weapons? Well, those same chemicals can also be nature's medicine cabinet. There's a painkiller derived from cone snail venom that's 1,000 times more powerful than morphine, but without the addiction problems. Can you imagine a world where spider venom helps people with chronic pain? Crazy, right? There are compounds from snake venom being used to treat heart attacks, stroke, and high blood pressure. Some spider venoms are being studied as potential treatments for epilepsy and chronic pain. Even scorpion venom is being researched for cancer treatment. It's like these animals have been carrying around the cure to human diseases this whole time, and we're just now smart enough to figure it out. Let me give you some specific examples that will blow your mind. There's a drug called captopril that was developed from the venom of the Brazilian viper. It's used to treat high blood pressure and heart failure, and it's saved millions of lives. Then there's exenatide, a diabetes medication that was developed from the saliva of the Gila monster. Yes, that big lizard from the American Southwest. Scientists are even working with scorpion venom to create tumor paint, a compound that makes cancer cells glow so surgeons can see exactly where the tumor is during surgery. It's like giving doctors X-ray vision. What do you think would happen if you got bitten by a snake that has venom made for hunting birds? The venom might not even affect you much because it's designed for a completely different type of animal. The chemistry behind all this is mind-blowing. Venom isn't just one thing. It's like a complex recipe with sometimes hundreds of different ingredients. Each ingredient has a job. Some break down cell walls, others block nerve signals, some prevent blood clotting, others cause massive inflammation. It's like nature's most sophisticated chemistry lab, and every species has their own secret formula that took millions of years to perfect. How crazy is that? And here's something that made me laugh. There are actually venomous mammals other than the platypus. Some shrews have venomous saliva. Imagine being bitten by something that looks like a tiny mouse and getting poisoned. There are even some birds that are venomous. The hooded pitohi from New Guinea has toxins in its skin and feathers. Nature really said, everyone gets a turn with the chemical weapons. What really gets me excited is thinking about how venom evolved over millions of years. It's like nature's ultimate arms race. As prey animals developed better defenses, predators had to develop more sophisticated venoms. Some animals, like honey badgers and ground squirrels, have actually evolved resistance to specific venoms. A honey badger can get bitten by a cobra, take a little nap to sleep off the effects, then wake up and finish eating the snake. Talk about being tough. But here's where it gets really mind-bending. Venom is incredibly expensive for animals to produce. A snake uses up to 20% of its daily energy just making venom. So venom has to be really, really effective to be worth that investment. Some animals have even evolved dry bites, bites where they don't inject venom at all. It's like they're giving a warning shot. So today we learned that venom isn't just for killing. It's an amazing evolutionary tool full of complex chemistry. From deadly snakes and spiders to the quirky platypus, nature keeps surprising us. And the best part? Scientists are using these venoms to create life-saving medicines. It's like turning weapons into healing tools. English Story Mode makes learning English fun by exploring these mind-blowing facts together. You've got this. Every episode is a step forward in your English journey. If you enjoyed today's episode, hit that subscribe button so you never miss a new story, give us a thumbs up, and drop a comment below. Tell us why you want to improve your English, or which science topic excites you the most. What's the hardest part of learning English for you right now? And which crazy science or nature topic should we cover in a future episode? I'm always looking for new ideas. And don't forget, there are 10 fun questions waiting for you in the description box below to practice what you learned today. Thanks so much for listening, my friend. I can't wait to see you in the next episode. Stay curious, keep practicing, and we'll see you next time on English Story Mode. Bye for now.